Welcome to day 2 of the right-try unit, the right-triangle unit. Right-try 3 says state the Pythagorean Theorem. The fact that it is a theorem suggests that we can state it in an if-then statement to clearly express both the hypothesis and the conclusion. So the Pythagorean Theorem only applies if we're talking about a right triangle. Now, in a right triangle there are 3 different sides, of course. 2 of the sides are interchangeable. Those are called legs. The third side is unique. It's called the hypotenuse. The way we distinguish the hypotenuse is its opposite, in other words, facing or not touching the right angle. If in fact we label these sides with letters, A being a leg, B being a leg, and C specifically being the hypotenuse. In other words, if a right triangle with hypotenuse labeled as C and the 2 legs labeled as A and B, then the following relationship occurs. A squared plus B squared equals C squared. That is the Pythagorean Theorem. It could be stated as a verbal or a worded statement, such as the sum of the squares of the 2 legs of a right triangle is equal to the square of the hypotenuse. If you're interested in the proof of this, that should have been your right-try 2. Right-try 2 demonstrated the proof using the geometric mean, suggesting that if this is A, this is B, this is C, and we call this leg X, then we know using geometric means that A squared is equal to the product of X and the whole leg of C, whereas B squared is equal to the product of this piece. Now, if this whole thing is C, how big is this? Well, that would be C minus X times that whole length of C. Multiplying this out, we get C squared minus CX. Multiplying this out, putting the earlier variable closer to A first, we get CX. Now, this is an equation. If I add this part of the equation to set it equal to the sum of these parts of the equation, plus CX and minus CX cancel, and I'm left with a proof of the Pythagorean Theorem. It says that that works. Okay, that's right-try 3. And a review of right-try 2.